Hello developers, let's start developing and take on the second part of day 8 of the 2023 Advent of Code. If you like this type of content, mash the buttons below, like and subscribe, and I'll try to have some kind of a exploratory development so to see what we can do with the second part of day 8. So, at the close of the part one, I mentioned something about cycles, and I'm quite convinced that this is the problem that we're gonna have to do because there's just no way that we don't get to Z, if it's possible to get to a Z in 2 billion steps, which means that we are kind of missing each other. So, what I will do, let's comment this out. We might need some variant out of it. But first, I want to see. So these are the start nodes. These are ordinal nodes that start with an A. And we're getting them nicely. So let's see for each of them. We're gonna see how long does it take them to get to a certain point, and that point being some Z. So I will just loop this. But instead of making a current node, I will actually let's do something first. The longest possible loop. Because if we want to loop, we want to make sure that we actually run a full loop. And the longest possible loop will be basically, so it might be, there might be a shorter one, because there might be a loop of length 3. But we want to make sure that we catch the longest possible one. And we have a loop in we are at the same place at the same time. And we have basically the number of nodes, which is this many, and the dir length, the length of the direction. So the longest possible loop is actually a multiplication of those. If they have divisors in common, it's gonna be less, but this is the theoretical maximum. Let's see how big that is. If it's in the billions, we're not gonna do it. If it's in something like a few thousand, we're gonna just loop through that. Since we want to investigate what is happening. So it's 216,000. Yeah, we can run a loop that long. So bringing back this part, we can just do a for loop while the index is less than the longest possible index, longest possible path. Well, move one step. Current node is start node, and then yeah, this is gonna be a let. We're gonna need the direction index, and then we do something along these lines. Get the next index, get the next node, left, right. And what I will do, if the current node ends with a Z, I won't return it because I want to keep running. I want to do a console log starting from start node. And I will also keep a step count. We're increasing that. We're going to increase dir index as well. And if the current node ends with z, we just console log found that thing in that many steps. That means we stepped on a z. We will get a lot of output out of this. So I will actually, so we have 6 by 2 times, it's going to be a few million. I will say debug.txt so we can get the data inside the text file so we don't have to scroll to the console. Yeah, so let's see what we have. So we're starting from GSA, and this is what I was looking for. So we do have a loop. We started at dxz in that many steps, and then in that many steps, and then in that many steps. And if I'm not mistaken, if we take 402 minus 335, that's 67. And then we have 67 again. So I will add a bit more code because I don't want to do math. I want the computer to do the math for me. No, we're not doing anything about the last cycle, but we're gonna write it out just to have the cycle length, and the cycle length will be the step count minus the last cycle, and then we're setting the last cycle to the current step count. Let's see how long a cycle we have. And if I'm correct in my assumption, we're gonna have a regular constant cycle. So the first one takes 335, but then we have a step of 67. And it's gonna go all the way to 200 and whatever we did. And this is the second one. So it takes 290 steps, and then we have 67 things, 59 actually. 301, and then we have 43. So we have 67, and then 59, and then 43. And you might notice one thing common about this, that these are primes. 67 is not divisible by 2 or 3 or 5. 6 and 7, 13. No, it's not. Or 7, because we know it's not. Or 11. And this one as well, and this one as well. So let's have this as once. And let's find out so far. So far, if we had to match only these three, this is their cycle length. So that means in every 169,979 steps, we will have the exact same situation for those three thingies. And this is going to pxz. We have another one. MQA goes to QLZ with a 79 step, not 49, 79 step cycle. and then we have AAA goes to 3Z to ZZZ with a 47 step cycle, and I guess we had one more. That has a 71 step cycle. Oh, so our answer will be a number that's about yay big. Let's format it and say this is a number with 1000 separators, so we can see that it's 44-ish billions. Yeah, so that's the case. So now we're gonna need to do some calculation. And since the weird thing is that if these numbers had a common factor, for example, if we have, let's say, 6 and 9, these have a common factor of 3 because this is 2 times 3 and this is 3 times 3. So it's not gonna get that each we have an overlap on 6 times 9, 54. We're gonna have an overlap on every 18th actually, because this is 2 times 3 and this is 3 times 3, and in this case we have 1, 2 and 2 threes that we can take care of, and 2 times 3 times 3 is 18. It's not 6 times 9, 54. But these are, all of them are prime, I think. We can ask Google. Or ChatGPT. That's a fancy thing. Or Wolfram Alpha or something like that. Let's try once more, because sometimes it tends to hallucinate. Yeah, okay, it kinda got it right. And to be honest, I was 99% that these were prime. So that means that the cycle that we have is actually this long. But when will this, on which iteration of this cycle will this occur? Because they have different lead-ins. So the cycle actually starts at the 300. We can say that the cycle actually starts at the 400, at the 336th step. And let's have a bit of a better output. Let's say, so we can output just a few things. Since we're doing exploratory, we can add a cycle count. That's 0. And we're gonna increase it here. And if we have, let's say, 5 cycles, just break the execution. Let's see that, and now we might not even need the debug.txt. Yeah, this looks mighty better. We can even lower this to 3. I'm not gonna go under 3, but 3 is enough. So we get 3 items, so we can see the cycle and it all fits on a screen. And now we have all the cycles, and it seems all of them are nice cycles. So we can describe basically each cycle with these 2 parameters. This is the offset and this is the length. And now we need to join the cycles somehow so that we can get a bigger cycle, because every 67 times 59, every 3953 steps, the same situation occurs regarding these two. So if they are both at the same time at the same place, then they will be again at the same time at the same place. But where does the first such occurrence occurs? I don't know. If they started with zero offset, then it's simple. It's gonna occur on this time. But we need to actually solve a kind of compound equation for this. And let's see if I can somehow brute force it. So, first of all, I will actually need to transform this a bit to get those data. So, I have this, and I'm not gonna do this. I say if the count is 2. So, on the second time that we actually get to the cycle, we know that we have the offset in the last cycle variable, and then we have the cycle length if we subtract those two. So I will define yet another type. I will call this is a cycle, and this has two parameters, and one is the offset, which is a number, and the other one is a length, which is a number. I don't need this equals. So yeah, these are the cycles. So if when we get to the second cycle, this is the offset, this is the length, and we actually just need to push it to the cycles. And then we can comfortably break. It suggests something. Let's see what it is. Yeah, find the shortest cycle. We actually we need the shortest combined cycle. But what we can do, we can just print out the cycles and see if we manage to get them all. Heh. We have our one off. Seems that we were not one off, but we put in the wrong numbers here. The last cycle is 0. Oh, we might want to do this here. That didn't help, so let's again think about where we messed up. Why is the offset always 0? It shouldn't be 0. Because we forgot this part, we deleted it. A bit better, but seems that we actually removed some things that we needed. Let's see what I was doing before when this thing actually worked. So let's have it as a 2. So now last cycle is 0. So last cycle is the correct one. Let's put this before the console. Let's actually use this as well. Let's see if it works now. And it's not gonna. Oh, actually it works. So what do we have here on the second time? 402.67. Let's log now this object, so where we have 67 is last cycle and step count minus last cycle. And this is the offset and this is the length. $335.67. Okay. And all of them seem correct. So now, yeah, we can remove the console logs now and go back to other R interfaces. Yep, that. And here, just instead of console logging it, cycles.push. You might need all of this to actually get the cycles, but I'm not gonna touch it. It works. We might do some performance optimization after this, but now we have a nice set of offsets and lengths. And notice that at this point, when we have the offsets and the lengths, we don't need anything else. All our map, every data that we had before, we can just throw them out because we don't care about them. This is where our answer lies. So this is definitely not going to be relevant because we have our answer somewhere around here. And I will say I will have this method, join cycles. Actually, I will have this method, 2 cycles. So I'm going to have a first cycle and a second cycle. And as a result, I want to provide a, no, I don't want to join them like that. I want to provide a cycle which will be the equivalent one of both of them. So what we will do, we will need to find when they start overlapping. And we can solve that mathematically or we can solve that with a brute force. So what I will do, I will actually generate their numbers. So the first cycle, let's just call it here, join cycles, join two cycles, join the first one and the second one. So there will be some console logging at first. So I will generate I can have, definitely not that, but I will generate the numbers using the cycle. So if we have the cycle data, the first number when we get to that is 335, and then we add length and we add length and we add length, so we can keep generating the numbers. So we can have a counter of some kind. And we're gonna need to have two of them. So the next number of the first cycle is this plus the length times the counter. The S next will be that many. And now we need to loop until we find the same number. Let's do that. So if found common node, F counter, S counter. So if they are the same. But if the first one is less than the second one, then we just increase the counter. Of course, if we have the other case, we increase the other counter. And we can loop until this is true. Because it is gonna become true eventually. And of course, we can say we need to break here. And we can actually run this calculation over here. So let's try to join the first two cycles. $39.53. I kinda doubt that. But let's use Excel to check that. The sheet. So we have our two offsets. So we have 335.67. 335 with a length of 67, and we have 295 with a length of 59. And this thing said that the coefficients should be 54 and 62. So if we take this number and add this number times this number, we get that thing. And if we get this number and add this number, here, this number and add this number times this number, we get the same number, which is the exact this number. Is it possible that this is our actual solution? Let's format it the way it should be. It shouldn't be because of the offsets, but One way to find out. Let's see if this number is our actual solution. No, it's not. Okay, that makes sense. It would have been too easy. But let's take the last two. But this is definitely a point at where they are joined. So from that point onward, we already know, we determined that they were primed. So this is their actual offset. From this point onward, at every this many items, we will have a cycle. So we can basically say return something that has an offset of f next, because f next and s next are the same. Oh, actually we don't need to break, we can just return where the break is. So the offset will be f next and the length will be first length times second length, because they are prime. There could, if they are not co-prime, for example, if they are 6 and 9, we can have a smaller length, but this also works. They don't have to be prime. For example, if you have 8 and 9, they don't have common factors, so their common length will be 8 times 9, 72. Okay, so I will just console log this to see what we get. And this time I think that we will get two same numbers, because their common cycle actually starts at 0. Yeah. And let's see if this is a pattern. It shouldn't be for all of them. There are quite a few options that we can do, since there are 6 of them. So the second, the third one, the fourth one, the fifth one, and then have this first one, the third one, the third one. Oh, the first one, the first one, the first one with the second one, the third one, and the fourth one. So we get some more cycles. In general, those two numbers don't have to be the same. And if they're the same all the time, then I'm gonna get weirded out. And I am getting weirded out, because this means that I have a bug somewhere. Okay, we're gonna need to do some more thinking, and in the meantime, I'm gonna actually do all the combinations that are possible. 1 and 4, 1 and 5, 2 and 1, 2 and 3, 2 and 4, 2 and 5, 3, 3, 4, 3 takes it with 4 and with 5, and this as well. We don't need the other console log here. And 4 needs to be combined with 5. 5, 4, 3, 2, 1. Those are the 6 options. So these are all the combinations, and it seems that they're all the same, since the offset needs to be lesser than the length, we will get that the offset is 0 all the time. And we are quite sure that the offset is not 0 all the time. It can actually be written like this, that we can have this modulo this. Yeah. So now we're getting that the offset is always 0 and that the offset is definitely not always 0. So we will need to do some thinking. I have a suspicion. I did some thinking in the meantime. I had a pause and went out for a smoke. And when you're thinking of a problem like this, it's always helpful to actually have some kind of a distraction. Maybe go out and walk the dog, maybe go out for coffee or something like that, because in the back of your mind, you're kind of thinking of the problem. And one thing that I noticed that is definitely relevant is that 335 is actually divisible by 67. So our offset kind of gets lost when we're doing like this. 59, that's also divisible. And 301 divided by 43, divisible. 316 divided by 79, divisible. And there's just no reason for this occurrence. 329 over 47, again divisible. And this is the last one. 355 over 71, divisible. So all of them are divisible, which means when I try to join these two cycles, I'm kind of getting the offset off because they do tend to come together at the same time. But let's see what happens and how. So after 54 iteration of this thing, oh, those numbers are kind of significant. Let's return this. Go a bit up, 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 up. Yeah. So we have this. It's not gonna come together after that many. Yeah, we have the same value here. But this is 5 off and this is 5 off as well. And then, which is the next one? Can we see which is the second time that they actually get together? Oh, of course we can. We can just say add another match counter, something like that. add it. Let's have it up to 5 times. So this is another trap that the task set in front of us, and we managed to fall inside of it. Because the offset does not have to be divisible by the cycle length. And our thing sucks because we're just gonna say we're just gonna increase the counters here one more time, each of them, so that we can find the next two. This way we just run into an empty loop. But it seems that it is okay because the second one is 2 times the first one. 3953 times 2 is exactly 7,906. So it means that they will have that amount of cycling done together. Let's see, maybe we had our solution, but we kind of shrugged it off. So let's try this. 1, 2, this is the first one. 3, 4 is these 2 cycles. 5, 6 is these 2 cycles. And then we're gonna call, yeah, these 2 and join these cycles. And this thing. Let's see how big the cycle is on this thing. It's the huge number that we got in Excel, as it should be. It's not that we forgot how to actually multiply unless we're missing something, and I don't think we are. But I don't know, let's try it this way. Maybe we mispasted it, but we definitely didn't. Make sure that you're using the full input data and so on and so forth. Yeah, we're using the full input data. Not that. So it seems that we hit a snag. Let's have another break and think about this a little more. And of course, after some thinking and analyzing and looking into stuff, I got the distinct impression that I might be doing something wrong when I'm finding the cycles, because it seems that it doesn't really make sense that the cycle is less than the input, the length of this thing, because this is 294 characters and or 293, doesn't really matter, and it doesn't look like it has a cycle of length 50 or something. So I had the feeling that it might be longer. And what I did find is that we forgot this part. We constantly increased the direction. So instead of looping back to the start of the input, we just continued straight on. And since we have this code here, it worked. I will actually update it like this and add another else that says let this blow up. And let's try to run it now, and now the mistake becomes obvious. Kaboom! Invalid direction. Why? Invalid direction. Undefined, because this is JavaScript. We ran out of the array and it just continued giving us undefined. Since the undefined is not left, then it has to be right. Now I will just add this thing here, comment everything else, and let's see what the cycles are. And this is something else. So first of all, what we need to do, we're gonna do this. The length is, yeah, is that, and the offset will be this modulo, the cycle length, and the length is the cycle length. Let's see our results. And now we have something else. So all of our cycles are real cycles starting from the very start, and they have this length. And you know what the funny thing is? We had some other numbers before. We had these numbers, and if we multiply these numbers by the length of the input, which is exactly 293, we're gonna get some other numbers. And those other numbers is actually the cycle length. So this means that this is our solution. And if I take this number and paste it in Advent of Code, it will provide me with that. And since I don't want to waste your time, I'm actually gonna do that. So we're not gonna need to join any cycles. We're not gonna do any kind of those things. So I will just say, well, we don't need to do run some we need to do a run a product, so I will need to do a reduce. So we're gonna start with 1, and since we need to find since 293 is a common thing, we'll take it out and then add it once, because that's how the mathematics work, because these numbers are no longer prime to each other, but they have a common factor, and the common factor needs to be taken out. So we will say, well, the cycle dot not the offset is 0, so the length. We're gonna multiply the accumulator by the cycle length, but divided with 293. Actually, direction dot length. Just to make sure that this works. What am I doing wrong? An initial value is not a cycle, is a number. Oh, and then we need to actually return the accumulator. Or we can just write it as a one-liner, but that's not gonna be a good solution because a one-liner will be kind of messy. So let's keep it like this, and now we just need to return the total multiplied by the directions length because we took it out and now we need to bring it in. And I'm kind of abusing a lot of the properties of this specific input. In no way did we have to have that property that the input is actually the cyclical length of all of these. But so it happened, so I'm just gonna do it. And I'm not sure if this works, but it kinda should. Let's see it here. So we have this huge lots of digit number, and that is our right answer because we finally managed to get it. If we didn't have that bug processing the input, transforming the data, the task would have been easier and solved quickly. And you can see that the problem was not actually that I had an error in my calculation, the cycle detection went fine, but our input was incorrect. So we had a situation when we had garbage in, garbage out. So if something doesn't work and your algorithm looks correct, try to see if your input is actually correct because you oftentimes kind of ignore that. Of course, another way in order to do this, the proper way, without managing anything cyclical, would be actually to implement a lowest common denominator. Yeah, lowest common container or denominator. I'm not sure about the English term, but something like that. And that algorithm would give us the same result. Abused actually, the two facts, and I won't do the LCD LCM or LC, whatever it's called, but I will write here the two facts that we are abusing. The facts that one, all cycles are not of the same length. All cycles have a common factor, which is the length of the cycle, which is a prime number. And all cycles have a common offset, which is 0. If it was not 0, we would have to do some other mathematics. And each cycle divided cycle length divided by the number of direction is a prime number. So that means that we can, if you are, in order to get the LCD of a prime number of two prime numbers, you just multiply them together. So that's what I'm doing there. I'm reducing all the cycle lengths to the prime number that's underneath, multiplying them all together, and then just multiplying by the direction length. So this won't work in general, but it definitely works for this input, as we can see that we are getting a better picture. We have the trebuchet, the snow island, the island, and now the two images of the desert island. We'll see where the thing takes us tomorrow. Bye for now. Keep developing. See you tomorrow.